to this Kali Linux course. In this module, I will demonstrate modern web fuzzing. We're gonna web fuzzing techniques using ffuf, brother. So like that. And the first command should be ffuf-h. And over here you can go through it and you can analyze whatever you want to know. But we're gonna go through it. So what is ffuf? Okay, ffuf is a high performance HTTP fuzzing tool widely used in professional penetration testing engagements. Okay, to expand the attack surface of web applications. Unlike traditional directory scanners, for example, ffuf allows flexible fuzzing of URLs. As you can see over here, you can go through the whole information, parameters, headers. You can check also post data, and even virtual host. Okay, so the first thing we're going to do is run this command. So let's run ffuf. So basic directory enumeration. Okay, so basic directory enumeration, we're going to run ffuf -u, and we're going to run this command. Okay, so we're going to run it. So in other words, let's run this. Here, I am performing directory enumeration, they call it, against the target web server. In this case, my target web server is Metasploitable. So let me open up Firefox, Mozilla, and Metasploitable. This is the IP, Metasploitable IP. So okay, so that's what we're doing, enumerating against the target web server. The fuzz keyword, for example, in this command, if you see it, the fuzz keyword replaces with entries from the word list. This is the word list. It's a default word list that you can find in Kali Linux. And when you update your distro, a lot of these tools are pre-configured. Like ffuf is already pre-installed also. So from the word, so that this -w flag specifies the word list used for discovery. Okay, this word. So and that -mc, for example, option filters HTTP response codes. Okay, allow me to focus only on meaningful responses such as 200 for successful pages, 301 and 302, for example. They are for redirections, and 403 for restricted resources. As you can see over here, 403, 403. This is very important directories, but they are restricted. So 301 and 302, they can be redirections, okay? And 200, for example, like this and this, they are accessible, successful pages, okay? So now I analyze the response codes and content size, okay? We can see the content size too. So A301 suggests redirections, like I was saying, and often indicating a directory. A403 means that the resource exists, but the access is restricted. Like for example, if you go through this information, for example, you'll find a lot of stuff. Let's go over here and let's check, for example, PHP info. Let's check PHP info. Now, if you do /PHP info, for example, as you can see, this directory, it gives you a lot of information. This is a security disclosure. Okay, so let me go. We're gonna go through explanation as I go through other commands so you can see it. So let's discover PHP files, for example. So this other command that you might run is ffuf. So you can be quick. I already have it here because I've been running too many damn commands, brother. You see, no. This command. So we're gonna run this command. As you can see, it has a .php. So what you will do is look for .php. Okay. So let's run the command. In other words, what I do in this phase, I narrow the attack surface by targeting PHP files specifically, okay? By appending that PHP to the fuzz keyword that we mentioned, as you see over here. I focus only on server-side executable scripts. As we've seen before, PHP, we checked it before in other sections of this course. But yeah, this technique is useful for identifying hidden administrative panels, like upload forms, configuration files, or test endpoints, okay? So I was telling you, for example, as you can see, we did this command with .php, fuzz.php, and it found that this was PHP. So we open PHP info, and it gives us the size and gives us the status that we can read there. So if we go over here, for example, as I was telling you, an exposed PHP info endpoint is a significant information disclosure vulnerability, for example, as reveals server configurations, reveals load modules, environment variables, and even software versions. So it's not good, brother. It's not good. So yeah, this is the type of stuff that you will find when you ffuf. So another command that you might use when you use this tool might be, like, in order to filter false and positive, you do it by response size, okay? So like, in modern applications, for example, sometimes return custom 404 pages with an HTTP 200 status code. And 404 pages are blacklisted, but it gives us a 200 status code, meaning that you can access them when it's not so. That's a false positive, they call it. So in other words, first what we do is observe size of normal pages. In this case, we notice that index size is for 891. Okay, that's the size. So we can run a code with that size that I have over here. Let me check too. Like, okay, this code, okay? So we're going to tell them to fuzz -w and the word list, and then we tell them to fuzz specific size, okay? So in other words, the -fs flag filters responses with a specific size. by removing responses that match the default page size. In other words, we isolate anomalies that may indicate hidden functionalities. Okay, so let's run this, and as you can see, it's beautiful, beautiful. Another command that you might use when you use this tool is for perimeter fuzzing, they call it. So if you didn't find, let's say you find something that goes index that, for example, if you find it that PHP, like this, something like that, page equals home, for example. If you did find something like that, you can run this command. So you run a command, so you do ffuf. Let's look for the command because, like I said, it's quicker for us. And we're going to see 3 different tools. Besides this one, we're going to see Gobuster too. We got Gobuster for you and Dirb. So we're going to see different tools, so you can have a better understanding or perspective of how they work. So for the moment, we are in here. So we're going to find the command I was telling you about. So ffuf. So we're going to turn to ffuf. Page. This ffuf. So what you do is you put you run this command. In other words, you see. In other words, now I am fuzzing a get parameter. Instead of discovering directories, I am testing possible internal page references, okay? This technique is commonly used to identify like local file inclusion, hidden modules, or administrative views. In other words, you can say that parameter fuzzing is powerful because many vulnerabilities exist in dynamic input processing rather than static directories. And we've already seen that with SQL injections and uploads when we created backdoors in previous sections of this course. So since it's going to run all these words, I'm just going to Control-C to stop it, okay? So now, another command that might be useful when doing virtual host fuzzing. Now, okay, you can run this command for virtual. So we do ffuf. So you're going to do ffuf, and let's find a virtual host fuzzing. Like this one over here. It should run, I think. Like that. Yeah. So here I am fuzzing the host header to identify hidden virtual host. Okay. And as you know, in enterprise environments, for example, multiple applications may be hosted on the same IP address, and you can see that when like all the websites, most of the websites they use one IP of one server, but in that server is 50, 60, 120 websites, for example. So that way too, so discovering hidden virtual hosts can significantly expand the attack surface. So that's another command that you can use. Okay, so let's Control-C. Now, how can we analyze the output like a professional? So when analyzing, for example, fuzzing results, I consider 3 main indicators. So in this case, I consider HTTP status code, for example. So if you go status codes over here, status code. This tells you what is open, what's not. So response size, as we mentioned, we checked it like this, and response time anomalies. Okay, so significant deviations often indicate hidden functionalities, brother. So that's how we do it. And so in this module, I demonstrated structured web fuzzing using ffuf, right? Rather than blindly running word lists, I focus on controlling enumeration, response filtering, and attack surface expansion. We're going to go through more tools as time passes by. For the moment, this is the methodology that reflects real-world penetration testing practice. Okay, so. In other words, fuzzing is not about running bigger word lists. It's more about interpreting patterns in the server behavior. Okay. So now we're going to move to the next tool. Okay, we're going to continue with the fuzzing module. In this case, we're going to see Gobuster Professional Script. So in this module, I will demonstrate web content enumeration using Gobuster. Okay. Now, as you know, Gobuster is a fast and efficient brute force tool written in Go. Okay, commonly used in professional penetrating testing for directory discovery, DNS. As you can see, the first command you can run is Gobuster-H, and as fuzz, for example, we've seen ffuf already. So we're going to see Gobuster, and over here you can see what it does. Okay, it tells you. So in other words, it's commonly used, like I was saying, for professionals penetration testing for directory discovery, DNS subdomain enumeration, and virtual host identifications. Okay, and many more parameters. So unlike generic fuzzers, for example, Gobuster is optimized especially for structured brute force enumeration tasks. So I'm going to show you, for example, let's go into phase 1, directory enumeration. So the first command you might run is Gobuster like this, Gobuster dash u, Gobuster dash u. Let me see if I have it here so it could be quicker. Gobuster dash u. This command you can run it, but you're gonna run into a problem. So you're gonna have to run this command. So okay, as you can see, so here I'm using Gobuster in directory mode, they call it. So directory mode. Okay, the directory option specifies directory enumeration. So it tells us. Okay, it tells us. So over here, it tells us directory enumeration. The U flag, for example, defines the target URL, which is this one, my metasploitable machine, like I was showing you. As you know, I work in a virtual environment. This is my metasploitable running, and so we were talking about. So the U flag defines the target URL. That -w, for example, this as in ffuf, it tells you the flag specifies the word list that we're using. Okay, and the S option over here, what it does, it filters HTTP status code, for example. Okay, allow me only to focus on meaningful responses. So, for example, a 200 result over here indicates success. How you call this? That is successful. Okay, so indicates accessible content, in other words, accessible content. 301, for example, like I was showing you before, and 302, often meaning is redirection, often meaning that resource is a directory, okay? Now, 403, for example, 403 and 3 indicates, as I said earlier, with ffuf, that resources, it does exist, but it has a restricted access to it, okay? Okay, so you can even see the size of each packet. So let's continue with this as in ffuf. So in phase 2, we're going to do enumerating specific file extensions, okay? So we do this one, ffuf again. Let's see if I got this command over here. With enumerations of extensions, like that. I was telling you that that should be, because this, let me run it without it so you can see. If I run it like that, I will have a problem because the new versions automatically has a status code blacklist for this. So in order and it fights with this other flag. So in order for that, to avoid the problem, you just run it like this. You just run it like I was showing you. Like this, and it will run. Okay, now, see, what we told them was, in this phase, what I do, I extend enumeration by specifying the file extensions using the X flag, as we did over here. The X flag, PHP, TXT, HTML, and so on, okay? These allow Gobuster to test multiple files type, such as PHP scripts, I was saying, text files, and HTML pages, okay? Now, this technique, as you should know, is effective for identifying backup files, exposed scripts, and misconfigured endpoints. So, testing file extension, what it does, it increases discovery coverage significantly in legacy applications. So it expands different angles where we can get into the system. Okay, now on phase 3, we're going to see another command for virtual host enumeration. Okay, so this command goes like this. Here. Yeah, host. Yeah, baby. Virtual host. No, virtual host. No, that's virtual host. I'm trying. There we go. Over here. So if we run this, for example. What I did was now I switched to virtual host mode. Okay, as you know, in enterprises environment, like we were talked earlier, multiple applications may share a single IP address. As in them host services, as websites I was mentioning, for example, GoDaddy and all of them. In one IP, you can find 40, 50, 100 websites using the same static IP, for example. So in enterprise environment, multiple applications may share a single IP address. So and by brute forcing host names, we can identify hidden virtual hosts that are not publicly documented. Okay, so that's how you do it. And discovering hidden virtual hosts, it can dramatically expand or attack surface, like we were saying during reconnaissance. Okay. Now another command, if we go to phase 4, is DNS subdomain enumeration, they call it. So let's do DNS Gobuster. Let me see if I can read DNS. Now, since my machine right now is not a website, right now I'm targeting an IP. If I run this command, it won't do nothing. But if it was a real website like www.facebook, whatever website you target to that you don't pen test to, it will give you in DNS mode. Gobuster tends to discover subdomains by brute forcing possible prefixes, they call it. This technique is essential during external reconnaissance to uncover staging environments, okay, like admin portals or forgotten development servers and so on. So in other words, Gobuster excels at structured brute force enumeration. It is extremely fast, reliable, and optimized for directory and DNS discovery. However, it is less flexible than advanced fuzzers when testing parameters and post requests, as with ffuf, okay? Now, in this module, we demonstrated systematic web enumeration using Gobuster across directory, virtual host, and DNS mode. So Gobuster is highly effective for expanding the visible attack surface during, like we were saying, reconnaissance phase early on. Now, let's move. So for this, we're going to finish here. We're going to move to Dirb. Okay, now we're going to move to a classic enumeration with Dirb. As you know, let's continue with the fuzzing module. We have seen ffuf, we have seen Gobuster, and now we're going to see Dirb. Now, in this module, we will continue the demonstration of web content discovery using Dirb. As you know, Dirb is a classic web content scanner widely used in security testing for discovery and file brute forcing. It comes pre-installed in Kali Linux. So, although older than modern tools, it remains useful due to its simplicity and reliability. So let's go to phase 1, which is a basic discovery scan. So the first command you're going to have to do is Dirb. Like that. I already have it like this, so it's okay if I can find it. The command. So in this command, you're gonna do Dirb, the URL, or now in this case is the IP of the target. We'll give them a word list, and we'll run it. And like I said, it's very simple. And it's funny because I've been using these different tools in different jobs or pen testing that I have done, and this is the oldest tool, as you can see, but there's some things that I couldn't find with one tool, so I used another one, and I did find it with another tool. So that's why I'm teaching you how to use different tools, so you can investigate and kind of process if the data that you got is correct. So as you can see, we ran Dirb. Dirb give us, as before, it gives us the size, it tells the code status, it gives us everything. So you can go, and you can copy this, for example. So this is so this, for example, you can copy and go look it up in your Mozilla, your browser. So I already had that open, so let's say we copy this over here. And you see, it gives us the information. That's the good thing about this. You can go and check everything. So you can go back again, for example, and if you find things that you want to investigate, like 200, like I said, like over here, there's another one. You can go and and check this. I mean, you don't lose nothing, and that's how you find that whatever vulnerability that you're looking for, and you go through it. The thing is that you gotta do what you got to do, brother. So let's do this, and there we go. Okay. Functions used in setup. Okay, now I already told you how this goes. So let's run another command, for example. So let's run. So with Dirb, I like Dirb. It's easy to use, but there are levels, right? Gobuster is very common and used in a professional way too, and ffuf is the main powerful tool right now. So let's continue with the next so pretty much here what I initiated direct brute force scan against the target, right? There will append each word from the word list to the base URL and analyze the HTTP response. So when output how can I say this? So Dirb automatically detects and reports discover path based on HTTP response behavior, like I just showed you. Okay, this is the path. Okay. It detects it automatically and it shows the path. So you can go and look if it is information that it's useful for you and so on. So you're going to have to do your own testing. So let's continue with this. So in this case too, remember we've seen the PHP info. So let's see this. So, no, this one, it doesn't open. Okay, so at least you can go one by one and check, okay? Okay, now, and I was saying unlike newer tools, they provide less granular filtering options, but it performs reliable baseline discovery. Okay, so if you go on phase 2, for example, with Dirb, you can custom extensions too. So you say Dirb. Okay, let's see Dirb. Let's do custom extension. Let's see if I can. Yeah. So you can run this command and you tell them over here. You see. So the X option allows me to specify the extension for testing. Okay, like in this case is .php, .txt, for example. Now, like I was saying, this expands enumeration beyond defaults directories and increases coverage, right? So you run this, and there we go. It does its job. Simple, easy. So okay, but like I was saying, Dirb is effective for quick baseline scans. However, it lacks advanced filtering, recursion control, and flexible fuzzing capabilities found in other tools like ffuf, okay, like we've seen with ffuf before. And so Dirb remains a useful tool for rapid content discovery, particularly in lab environments or legacy systems. However, modern engagement typically require more flexible and scalable fuzzing frameworks. So to summarize everything, you can say that Dirb is a classic and simple directory scanner. Okay, Gobuster is fast and structured brute force enumerator for directories and DNS, and ffuf is a flexible HTTP fuzzing engine capable of testing multiple components of a request. In modern penetration testing environments, like I was saying, ffuf is often preferred due to its flexibility and advanced filtering capabilities. Okay, brothers and sisters. So that you have it there. What else can I do for you, player? What else can I do for you? So now this is over for this module. We're gonna go on to the next. We're gonna do privilege escalation on the next module and section of this course, and we almost finished in this beauty. Okay, take care, players. Hackers, don't forget